Welcome to our lecture on wearable technology, where we are going to talk about gear that can be used to measure biomechanics in natural environments. And in 2024, this was actually the #1 health trend, according to exercise science specialists, for areas that are becoming more popular within the exercise science community. So the primary objectives of this lecture are to be able to identify pros and cons of laboratory and in the field collections, and to be able to identify the appropriate use and available data that can be pulled from wearable sensors. So when we talk about the collection settings, traditionally, research was performed in the laboratory, which was a very controlled environment. And so this was desirable because it will minimize errors and allow for consistent lighting and temperatures, which may have an impact on performance. But it's different than a real life environment. And oftentimes the equipment that we use in a lab isn't portable. Okay, so when we're interested in measuring injuries, we'll measure movements in a lab. Injuries don't happen in the lab. So are we actually getting the most accurate representation of movement patterns in a natural sport environment? So this is where in the field, collections have come into play, or sometimes referred to as the wild. And this is where collections are performed in a more natural environment. So it could be during a practice, it could be kind of outside, as anywhere not confined to a laboratory space. Now, while this does give more real world collections, there is much less control over the environment. And so there may be other factors that influence something that we're not able to account for that can influence the results. Now, there's tons of different tools that can be used for in the field analyses. We're going to talk about a few of these and how they can be applied and what type of information you can pull from them. So first off, we have timing or velocity systems. And so the timing devices we have, these can be stopwatches or timing gates. They can have a manual start and stop, or they can be started and stopped based on different pressure sensors or infrared lights. So this allows us essentially to measure someone's velocity. A lot of times these will be used for your straight line races. Velocity devices include radar, LiDAR, and GPS systems. So radar uses a microwave radio signal that reflects off the object and comes back to that radar gun that's being used. And so this has what we call a Doppler effect, where this is going to look for the shift in the frequency of the signal as it's bouncing back. LiDAR is similar to radar, except it's going to use a laser reflection. And so this is going to be more accurate than radar, because radar with the Doppler effect, those sound waves kind of reverberate and spread out, whereas the laser reflection is going to be more direct back to the source. And then you have GPS systems, which are global positioning systems, which essentially uses satellite-based navigation systems. And so from this, you can get the position and location, which can then be used to calculate the velocity when you incorporate the time with it. Okay, so these GPS systems, a lot of soccer teams start to use them, even basketball teams. They kind of look like sports bras, and this can essentially track how far an athlete has run during a practice or during a competition, and the different velocities that they incorporate. So you can see, okay, during this practice, they were about 75% of the time, they were running at a relatively fast velocity. So maybe the next day of practice, we need to have a little bit easier practice that's not as challenging. Now, we can also use devices that are called accelerometers, and these are going to measure the linear acceleration in a specific direction. So accelerometers can either be uniaxial, which means they measure in one direction, or they can be triaxial, which means they measure in 3 directions, and these 3 axes form right angles with each other. These can be used to measure essentially the vibration or impact. And so think about this with collisions. You find these accelerometers in football helmets. And so now NFL and college has it where if someone gets a hard hit and there's a certain linear acceleration that's detected by this accelerometer, they'll get flagged by the athletic training staff. Hey, do an assessment to them to make sure they didn't suffer a concussion. Accelerometers are also used for pedometers, which count the number of steps you take. A lot of watches are going to have them. Smartphones have them and are used to measure sleep patterns if you sleep with your phone on the bed. And so really, these are just looking for these change in linear acceleration. There's also gyroscopes, which are going to measure the angular acceleration in a specific direction. So just like accelerometers, they can be uniaxial, which means they measure in one direction, or they can be triaxial, which means they're measuring in the three directions. And now this is essentially going to tell us the orientation or the projection of the motion that's occurring. And so this essentially tells us what type of rotation is occurring. Well, accelerometers just tell us that linear acceleration. This gyroscope tells us the change in the angular motion. And then we have magnetometers, which are going to use magnetic forces in relation to the Earth's magnetic field. And this allows us to calibrate data according to where the position where something is located. And so if a conductor is placed in a magnetic field, there's going to be this voltage generated across the conductor that's perpendicular to the field. And so that change in voltage is what's used to identify where the object is in relation to the Earth's magnetic field. Now, the accelerometer, gyroscope, and magnetometer can be combined together into one unit, which is called an inertial measurement unit, or IMUs. And so what these can do then is that they can tell you the acceleration, orientation in space, and the direction of this motion. And when you pair multiple of them together, you can actually recreate a skeleton model. There's also been this new development where in textiles, which is when people wear clothing that are embedded with different sensors. And this then allows a recreation of the different body segments. So you can see in this image, this woman has on a textile, and which is essentially a bodysuit, which is then converted over into this animation right next to her. So you can see how well it captures her movement. These are beneficial because they're lightweight and flexible and breathable, so they're not going to restrict your natural sport motions as much. And what these use, textiles essentially are looking at kind of the stress and strain, and they're measuring energy storage within the different sensors placed in the suit to then identify the motions. Pressure sensors are also used to identify kind of how pressure or how force is dispersed over an area. And what these will use are strain gauges, which measures the change in the electrical resistance in a current when there's some type of compression that is placed on the gauge. And again, this is just telling us how those forces are distributed, because pressure is the force divided by an area. And so a lot of times there's these insole pressures that go in shoes. And so you can identify maybe someone's having foot pain, and it could be due because they have higher pressure in that area. And these pressure insoles can identify, okay, yes, we do observe a higher pressure here than we typically see. So maybe we need to work on distributing that pressure elsewhere along the foot. Now, what are some applications of these wearable technologies? So there's kind of three main ways they're used. You have lifestyle applications. So think about these as your smartwatches. These track your steps you take each day. They can track your sleep. A lot of them will have these calculations of saying, oh, you had a stressful day yesterday, so try to have an easier day today. So give you an overall sense of wellness. They can also be used for performance. So you can use these devices to identify top speed, distance traveled, can even be used to estimate vertical and horizontal jumping, and even the trajectory of projectiles in the terms of how can we use this information to improve our performance. And then it's also used for injury tracking. So they're in helmets. You can wear these sensors that can track different counts of pitch counts and loads. So these can be helpful for monitoring overuse injuries. They can also give you an idea of the intensity level and identify when there's high levels of forces that occur. Now, of course, there has to be some considerations with these wearable technologies. A lot of times, these companies develop products and say, you know, we can tell you all this information, but they're not necessarily telling you how that information is calculated, and so you don't know how accurate or valid it is. Okay. There's also these considerations with how the sensor communicates with the system as a whole. So a lot of times wireless communication is going to be essential because wiring can limit or restrict motion. But with that wireless, you have to make sure you're able to send and receive the data, and maybe it has to be within a certain range of the receiver. You have to keep in mind power consumption. So a lot of times the base station, it could be a computer or it could be an app. So if it's a computer, you obviously have to have some type of computer outsource. If it's an app, that's usually going to be more portable. but making sure you have batteries that will last for the duration of the collection. And then also keeping in mind the size of the sensors as you're attaching to the body. Something that's a little bulkier, it's going to increase the mass on that segment and could influence movements to it. And so the smaller the sensor, the less disruptive it is compared to normal. Okay, and like I said, we don't necessarily know how these calculations are being made, and these devices need to be validated against the gold standard that we use in the lab. And so hopefully the terms reliability and validity are familiar to you. Reliable meaning that it can reproduce consistent results, valid meaning that it produces accurate results. And so you can have it where it's reliable and not valid. So here you see this clustering. While it's consistent, it's away from the target. Here, if you take all the average of these points together, it would be right in the middle of the target, but so it would be considered valid, but it's not reliable because you're not going to get consistent results. Here, you're going to get both valid and reliable, a clustering of results all in the middle of that target. And then you've got neither reliable nor valid. We're not hitting the middle of the target, and they're kind of spread out. Okay, so some of these newer technologies might be reliable, where they can give you consistent results, but they're not necessarily measuring what they're intended to measure, or they could be not valid and not reliable, and you can't really trust them as well. So don't always believe what they are trying to sell you on until there's evidence behind it that yes, this does indeed measure what it's intended to measure, and you can trust that it's going to be consistent with its results. So that's an overview of wearable technology that's used to kind of advance the field of biomechanics as we move outside of the controlled lab settings and into the field and more real life collections. If you do have any questions, go ahead and write those down, bring them to class, or post them on the discussion board, and we'll chat about wearable technology when we meet next.